increase in emissions. Consistent with this, Project Drawdown, referenced in the film Kiss the Ground, estimates the total carbon sequestration potential of improved managed grazing at 13.72, 20.92 gigatons CO2 EQ between 2020-2050, equal to 0.46 teropont GT CO2 EQ per year. A 2022 peer-reviewed paper estimated the carbon sequestration potential of improved grazing management at a similar level of 0.15 to 0.70 GT CO2 EQ per year. A research made by the Rodale Institute suggests that a worldwide transition to regenerative agriculture can soak more than 100% of the CO2 currently emitted by people. Nutrient cycling. Soil organic matter is the primary sink of nutrients necessary for plant growth, such as nitrogen, phosphorus, zinc, sulfur, and molybdenum. Conventional tillage-based farming promotes rapid erosion and degradation of soil organic matter, depleting soil of plant nutrients, and thus lowering productivity. Tillage, in conjunction with additions of inorganic fertilizer, also destroys soil microbial communities, reducing production of organic nutrients in soil. Practices that restore organic matter may be used to increase the total nutrient load of soil. For example, regenerative management of ruminant livestock in mixed crop and grazing agroecosystems has been shown to improve soil nutrient cycling by encouraging the consumption and decomposition of residual crop biomass and promoting the recovery of nitrogen-fixing plant species. Regenerative crop management practices, namely the use of crop rotation to ensure permanent ground cover, have the potential to increase soil fertility and nutrient levels if nitrogen-fixing crops are included in the rotation. Crop rotation and rotational grazing also allow the nutrients in soil to recover between growing and grazing periods, thus further enhancing overall nutrient load and cycling. Biodiversity. Conventional agricultural practices are generally understood to simplify agroecosystems through introduction of monocultures and eradication of diversity in soil microbial communities through chemical fertilization. In natural ecosystems, biodiversity serves to regulate ecosystem function internally, but under conventional agricultural systems, such control is lost and requires increasing levels of external anthropogenic input. By contrast, regenerative agriculture practices including polycultures, mixed crop rotation, cover cropping, organic soil management, and low or no tillage methods have been shown to increase overall species diversity while reducing pest population densities. Additionally, practices that favor organic over inorganic inputs aid in restoring below-ground biodiversity by enhancing the functioning of soil microbial communities. A survey of organic and conventional farms in Europe found that on the whole, species across several taxa were higher in richness and/or abundance on organic farms compared to conventional ones, especially species whose populations have been demonstrably harmed as a direct result of conventional agriculture. AMP grazing can help improve biodiversity since increased soil organic carbon stocks also promotes a diversity of soil microbial communities. Implementation of AMP in North American prairies, for example, has been correlated with an increase in forage productivity and the restoration of plant species that had previously been decimated by continuous grazing practices. Furthermore, studies of arid and